Wonderful. Well, thank you all for joining today. Thank you. You know, it is so good to be back here in person, actually talking to people face to face. And I know from my perspective, I've had just great conversations so far that you really can't replicate anywhere else other than right here. So again, quick introductions from our end. My name is Adam Cason. I'm Futurex's Vice President for Global and Strategic Alliances.
And I'm Sam Pfanstiel. I'm Principal at Coalfire Systems.
All right, and today we're going to be talking about a fun subject, and it really weaves in a lot of different things that relate to data encryption, key management, cloud, and all the different standards that we know and love here, and that's HSM Virtualization. So we're going to talk about that, multi-tenancy, we're going to talk about how those interact from the standpoint of the end user, from payment application developers, from the assessor's perspective, and from the developer perspective for HSMs as well. So, you know, with that, let's go ahead and take it away.
You know, I think before we do, it's probably a really good idea to just kind of look at some of the drivers that have brought us to where we are today. So it should come as no surprise that cloud infrastructure has been growing tremendously. We've seen 20% year-over-year growth in cloud infrastructure and technologies, which this year is forecasted to reach 500 billion euro. And so concurrent with that trend are the technologies both in software and hardware which have driven cloud adoption. Virtualization chief among them. So virtualization, of course, whether we're talking about containerization, VDI, virtual networking, distributed file systems, these have all reached a greater level of maturity. And a lot of that's in part due to both the software development, but also the underlying hardware, the memory isolation, user space, and process level, kernel level operations that we're able to achieve true isolation, both with virtual I/O and other hardware advancements. Concurrently, we have drivers for in the compliance space: GDPR, PSD2, ISO 27002, 27799, and of course PCI DSS and software security framework, all relying in part on the protection of sensitive data. Of course, we think of point-to-point encryption also being heavily influenced by the use and adoption of HSM, and we'll talk more about that as we move forward. So another trend, of course, I don't need to remind too many of you of what we've been through over the last couple of years with the global COVID-19 pandemic and the trending toward the virtual workforce. So this has caused us to rethink some of our perimeter protections, increasing adoption on trust-based authentication and for access to sensitive enterprise resources. Of course, don't be fooled. Even zero trust models rely heavily on certificate-based authentication. Again, pushing and forcing adoption of cryptographic services. So all of these growth and changes, sorry, I haven't been advancing my beautiful slide. So we've got the virtualization, we've got encryption of sensitive data and data protection, this distributed workforce, and of course, certificate-based authentication, digital trust. So these have moved and forced the internationalization of these our workforce has really increased the adoption of secure access service edge technologies, which have pushed a lot of the cryptographic services out into various regions and locations, rethinking the idea of perimeter protection and ensuring availability of cryptographic services at the edge. So it should be no surprise then that we see increasing adoption or increasing presence of HSM in our security standards. Now, in our industry, we see a very specific set of cryptographic use cases for HSMs, right? So again, as I mentioned, point-to-point encryption sometimes gets held up as somewhat of the flagship of use of HSM because of its reliance upon the data encryption as well as decryption and the use of HSM for these. But also we see payment-specific functionality like duckput and PIN verification, which also are performed within specific payments functions within payments HSMs to ensure that the sensitive key derivation processes as well as the PIN is never present outside the boundary of a secure cryptographic module. Key generation processes also utilizing specific functions in the HSM ensure the enforcement of dual control and split knowledge and a quorum of custodians. And these generation and management processes, of course, relying on sufficient entropy provided by the validated random number generators within these devices. Signing of public certificates, public key cryptography is also crucial to be done within the HSM, and also code signing as well. So we see a number of these processes which all rely upon the ability to trust a hardware root of trust. And so the physical presence of a non-software but physical HSM gives us that ability to trust that these cryptographic processes are genuine and have the integrity that we require. So Adam, how does that really play into the whole HSM virtualization?
Oh, absolutely. And so at the end of the day, virtualization and multi-tenancy in the HSM or hardware security module world, it's all about a consolidation play. And seeing that slide up there with all the different use cases, it kind of strikes me as fun. And I know it will for a lot of people in here who've also been in the industry for decades at this point, where you go back 10 years, give or take, you're going to find people saying, A, what is an HSM? But B, using it for a relatively small number of use cases for data encryption and key management. Now, today, we're seeing tons of different use cases come up. Database encryption, certificate authority and PKI, integration with hundreds of different general purpose applications out there on top of the payment application side of things. And so with that, one of the biggest trends we're seeing these days, especially in the enterprise and tier 1 marketplace, is that organizations with so many different needs for strong cryptography and key management, they're trying to consolidate that. They're trying to bring that into a single infrastructure, often managed by a dedicated encryption services and key management team, rather than saying, all right, we've got 10 different mission critical applications that need cryptography. Well, we're going to let each business unit figure it out on their own. You end up with 5 different vendors, you end up with differing firmware versions, you'd end up with different training regimens. It's a mess, right? So what we're seeing is people bringing those in, organizations bringing those into a single infrastructure. That way you can have better management control, you can have easier times just day in and day out dealing with it. But how do you deal with that from an actual separation of sensitive data perspective? You can't have all of those applications sharing keys, sharing processing resources, anything like that. So enter HSM virtualization. And that really is the process through which a single physical HSM or a cluster of physical HSMs can be logically subdivided out into multiple separate virtual HSMs. Each of those virtual HSMs running an independent containerized version of the HSM firmware. They've got their own keys, key versions, their own security policies, users, network stack, really everything about it. From the application perspective, you shouldn't be able to tell that it's a virtualized HSM or whether it's a physical one. There's no real difference. Now we'll talk about partitioning in a minute, and that's going to be something a little bit different, and we'll talk about some of the differences there. But what is HSM virtualization not? Partitioning. Now that's not to say that partitioning is a bad technology. It's not. In fact, partitioning and HSM virtualization are often used in very complementary environments where you can have a need to use both simultaneously. Now, one other thing that it's not would be a software-only HSM. I talk to people all the time, and we say HSM virtualization, and they think, oh, great, so I can run it inside my public cloud provider, or I can run it in software, or spin up a VMware instance. That's not it. At the end of the day, to have true, compliant, productive HSM virtualization and multi-tenancy, you can't get away from the hardware aspect of it. A software, hardware, security module, right? It doesn't work, right? And that's what we're talking about here as well. So let's dive now into the multi-tenancy models that we see. So we talked a little bit about HSM virtualization and how that works, but partitioning. Partitioning is an interesting one, and that's been in use for actually a lot longer in the industry than true virtualization has been. And partitioning essentially is where you divide out 2 things on the HSM. One would be internal key storage space, and the second would be permissions for various API commands, functions, things like that. So as an example, you might have partition number 1, and that would use keys 0 through 5, and it has access to the translate pin function because it's being used for pin translation. Maybe partition 2 might be used for transaction macking or something like that. It would have different keys there. And that's fine. There are some situations, some, not all, where you can do that level of segmentation. However, there are some issues with it. The first is that most payment applications don't support authentication with the HSM. And in order to effectively use partitioning, the partition needs to know which application is connecting to it, so it can know what keys to allow access to and what different API commands to allow. It also requires there to be control over quality of service. If you have one application that's using symmetric key cryptography, doing, let's say, triple DES or AES pin translations, and then you move with another application that's using RSA key generation, well, if there's no way to say, how fast can those go? If there's no way to divide out resources, you might have one application saturate the entire HSM's throughput, effectively rendering it worthless in a true multi-tenant environment. So that's where HSM virtualization comes in, among other things. You can control how much of one particular throughput resource or things like that are allocated to it. Then why use it? We've talked about infrastructure consolidation and how that's big, big, big right now. We're seeing huge trends towards that. A lot of that is towards cost optimization within the individual enterprise, and that's a pretty clear, pretty easy to understand concept. Take many teams, each dealing with their own HSMs, you combine them into one or a smaller group, you have better control, you have people that are more well-versed in the security and compliance and the operational side of it. Like that just makes sense. But one of the things that I personally find really interesting, and especially for the payment application providers out here today, this is something worth looking into. Quite often with the application providers, they go through their sales cycle, they sell the customer on their application, everything's looking good, and then they say, oh, you have to have an HSM. So go talk to whichever vendor you want to go with and go through their sales cycle, and it ends up causing a little bit of a speed bump in there. And so with HSM virtualization, with multi-tenancy, with the whole as-a-service model, a lot of the application providers these days are looking to bring that into their own house, to be able to deliver that bundled together with their applications, not only for streamlining their own sales cycle, but also a little bit of a revenue generation opportunity as well, where they can look at different ways to increase their value to the end customer. So it's interesting.
Yeah, and it sounds like, so those two models, or maybe the two segments that might be heavily interested in this would be the payments enterprise, the fintech or financial services organization that has a number of payment applications. They would need that ability to separate the business units with the ability to fully isolate those keys. And I think that's right. An important point you make, right? When with partitioning, there's one master key that generally governs all of those subsidiary keys. And it sounds like the ability then to scale, I mean, obviously every enterprise needs that ability to scale their applications. And I see a parallel there, of course, security being an important portion of that calculus with the cloud service providers, which obviously are investing heavily in virtualization technologies and are very influential in our industry, allowing us the ability to really scale our own individual merchant or other organizations using these technologies. And that's certainly that parallel, right? The ability to isolate their customers fully from each other. And we'll talk about the DSS 4.0 implications of that here in a moment. But also the ability to achieve true hyperscale while allowing their customers control over their security policies. Because as an assessor, I have to come in and look at whether it's 3D secure or P2PE, that you've enforced the security policies on your HSM that are specific to the requirements.
Exactly. Yeah. I mean, you go in and you talk to some of these fintechs and neobanks and companies that were born in the cloud, and you tell them, hey, I know you're doing everything in the cloud, everything except not the HSM. You have to have that on-prem. They look at you like you have three heads. It's just, it doesn't make sense to them, and this really takes a different angle.
Yeah. So what does that look like in the real world that you're seeing at Futurex?
So it's interesting for us because we're seeing really these things here that sometimes they're worthy considerations, sometimes they're not. And the data residency one in particular is interesting because there's a lot of, to be quite honest, there's a lot of misinformation out there around data residency, around what constitutes sensitive data and what doesn't. At the end of the day, it's a regional thing, it's a country-specific thing, and for those implementing this type of technology, whether it's virtualization, multi-tenancy, but more often than not, cloud-based HSMs, looking at the regional or country-specific data residency requirements, very, very important. And I've actually seen some where they say, well, test data, even for development in UAT, that's also within the bounds of data residency. I've also seen others where they get into that situation and then they look at it and they say, well, maybe we can make a good argument that'll get accepted by the various regulators out there. So it's something interesting. Secondly, looking back to the single group that manages encryption services and key management. Well, if you're taking all of these different applications, either as a single organization or if you're delivering these services as a SaaS model out to prospective customers, you have to have much, much, much more robust managerial and operational control. And then, like Sam was saying, to build on that, How does this factor into your overall cloud plans? How does this align? Are you able to connect in directly from your hyperscaler cloud environment to your cloud HSM environment? How does multi-tenancy play into that? And then finally, looking at all the different applications out there, how do you weave together all your general purpose applications, all your payment applications in a cohesive way that still remains in line with the standards?
So obviously we're all here for the PCI community meeting. And so how is PCI responding to these these changes in our industry? So in 2020, I was honored to be part of the Cloud Cryptographic Services SIG. And part of that initiative was to make recommendations for the PCI PTS HSM version 4 standard, as well as updates to the cloud security guidance document, which have been published. Now these changes do include in PTS HSM 4 changes that are very thought-provoking. Right, so we now see the context of this idea of a cloud-based HSM as a service. Now this feature set is not utilized by any of the other standards yet, but we're looking to see how this will be implemented by PCI in the coming days as they make adaptations to their standard revisions. This establishes the idea of an HSM solution provider as well as an HSM customer. So we know that this model will take on some form or fashion that will allow us to utilize and for various enterprises and CSPs to utilize this model. The multi-tenant HSM is also established as a functionality, and so we know that this the multi-tenant HSMs will be PTS HSM approved device features. And finally, the remote managed HSM. Now, the remote managed HSM is specifically intended to be used dedicated to a specific organization. So this may have a different application, perhaps, for the payments enterprise. But insofar as the remote access capabilities allow for satisfaction of true encryption and protection of keys for remote key management, we expect to see some of this take place and perhaps update some of the standards with respect to remote key management. So let's look quickly. We only have a few more minutes. These slides will be available, but I want to talk. So as a QSA, P2P assessor, as well as a 3DS assessor, SSF, and token service provider, I speak to a few of these topics. Now, I'm also going to mention CPOC, SPOC, and card production. Neither I nor my company are engaged in those services, so definitely check with your assessor, the Security Standards Council, or the brands about implications of these. Now, we do see some soft changes in the PCI DSS4, which we'll be discussing, of course, this week, which allow for the use of an HSM for the protection of keys for card data at rest. Also, with the customized approach, now, keep in mind, you do have to perform a targeted risk analysis. And if you're an enterprise that protects millions of cards, and your targeted risk analysis for your customized controls intend to utilize some sort of a customized approach, I guarantee you, you're probably not going to get away with using a software-based key management scheme. Third-party service providers under requirement 12 now are explicitly required to have a shared responsibility matrix under 12.9.2. And while we've seen a lot of adoption of that anyway under the previous PCI DSS 3.2.1, the importance here is that if you are providing a shared responsibility for management of, say, firmware as well as security policies on a virtualized HSM, these need to be clearly documented as part of the shared responsibility matrix. And finally, we of course see Appendix A1 renamed from the shared hosting to multi-tenant service providers, and I think that's indicative and reflective of this idea of the use of the terminology for multi-tenant. Within Secure Software Framework, again, the idea that you can rely within the execution environment upon an HSM certainly leads to the importance of providing vendor security guidance for the controls that are expected to be in place for the protection of those sensitive data. And finally, within some of the hard requirements, again, consult with the standards and your assessor, but I've notated some of those here. As we mentioned, virtualized HSM does have the ability to have sets of firmware and security policies loaded within each VM. So think of your HSM as a hypervisor and each of those VMs as guest operating systems, but instead of operating systems, we call it firmware. Well, each one of those will have its own, can have its own configuration, and that's highly important when you're looking at verification of security policies for P2PE, PIN, 3D Secure, and token service provider. The ability to isolate that crypto system, as I mentioned earlier, where the service provider does not have access to any of the keys and can ensure a full separation of the access to the sensitive key crypto system, very important, especially when you start talking about with DSS4 and that requirement now that's new that requires that the cloud service provider or any multi-tenant service provider can demonstrate full logical separation of these important access to customer information. Now, I've notated here some remote access requirements. While not specifically affected by the HSM virtualization, if you're working in 3D Secure or TSP, P2PE, and PIN, keep an eye on how these standards may reflect the new feature of the remote HSM, the remote managed HSM, insofar as clear text keys, both loading and use.
Well, and thank you to everyone for joining us today. This is a heavy topic. There are a lot of different facets of it. Sam and I are both going to be around the rest of the week. We'd love to answer any questions anyone has. Just come and find us. Thank you again for spending time today. And Sam, always good sharing the stage with you.
Thanks, Adam.
Thanks.
Thank you.